Okay, so let's go over your homework. Question number 5 is a ground to ground. We're told that the delta dx is 60 meters. We're told the total time in the air is 10 seconds. And it wants to know the VI and the theta. There's two ways you can do it. One way is when you look at your givens in the x direction, you might realize you can get VIx right away without separating it into VI cos theta. So you could do delta dx is equal to VIx delta t, and then the 1/2 ax delta t squared, of course, which goes to 0. And you can solve for VIx. So VIx will just equal delta dx over delta t, 600 meters over 10 seconds. VIx is equal to 60 meters per second. And then you can go to the y direction, and you can use our little trick of AY is equal to VFY minus VIY over delta t, and we can call it TU, and this goes to 0. And we can range for VIY, so VIY will be taking the negative to the other side, negative AY delta TU. So VIY will equal negative 9.81 meters per second squared, and the time was 10 seconds, so 5 seconds. So you end up getting a VIY of 49.05 meters per second. And so then you can go back up here, now that you have your x component 60 meters per second, your y component 49 meters per second, you can square them, add them together, take the square root, and do the tan. And I trust you can do that on your own. There's another way you could solve for it, though. If you broke it down into VI cos theta and VI sine theta, then in the x direction you'd have your VI cos theta delta t, but you'd have two unknowns. And so then if you went over here where you had your AY was negative VI sine theta over TU, you also have two unknowns. So you could do systems of two equations. I'd probably multiply this dude by 2, so I'd have my t in both. Whoops. Multiply by 2 over now just delta t. And then rearrange for VI. So take the delta t, the negative over, so it'd be negative AY delta t. And on this side it would be equal to VI, oh, there really is a theta there, sine theta. And I'd probably rearrange for sine theta. Oh yeah, I forgot the 2 again. There it is. So I'd keep the sine theta, substitute for VI. So VI would be equal to negative AY delta t over 2 sine theta. And then take this and fill it in up here where your VI is. So delta dx would be equal to negative AY delta t over 2 sine theta, and then times cos theta delta t. Now you have to be careful because there's sine theta cos theta, which is tan theta, but look, it's upside down. So it means it's really 1 over tan theta. The tan theta has to go on the bottom. So to be negative AY delta t would be t squared, and it would be over 2 tan theta. And then you can rearrange for tan theta. So tan theta would equal negative AY delta t squared over 2 delta dx. And then fill in your numbers, and you'll get your tan theta. It's like 39.727 maybe. And then you'd fill it in over here and find your VI. Okay, so both of these ways work. Does not matter to me which way you do it. I'd say do it the way that makes sense in your head, that you see when you start the problem. I just thought I'd show you both ways in case some of you did it one and some the other. Okay, so now number 6, it doesn't clearly say that it's a ground to ground, but it has to be. The hint is perhaps it asks for delta dy max, but you have to assume the catcher's catching the ball at the same height the person's throwing it. And it tells us that the horizontal component of the initial velocity is 20 meters per second. So that's your VIx. And from that you can find your time. So again, delta dx is equal to VIx delta t, 1/2 ax delta t squared. This goes to 0, solve for delta t. And it's just delta dx over VIx, 80 meters over 20 meters per second. And so the delta t is 4 seconds. Now that we have that, we can find our VIY looking at just the up. So again, AY is equal to VFY minus VIY over delta T. If we're looking at up, this is U, that goes to 0. Negative VIY is equal to AY delta TU. So VIY is equal to negative 9.81 meters per second squared times 2 seconds. So VIY is equal to 19.62 meters per second. And then once you have that, you can do delta dy max is equal to VIY delta TU plus 1/2 AY delta TU squared. So delta dy max is equal to 19.62 meters per second. Half time would be 2 seconds plus 1/2 negative 9.81 meters per second squared, 2 seconds squared. And so the second term, remember, it'll be half of the first term. First term is 2 times 19.62, so and this one will be 19.62, so you'll end up with 19.62 meters. And when it's 2 seconds, that always happens, that the VIY and the delta dy max are the same. Okay? All right, number 7, a non-ground to ground. So in 7, you're looking for delta dx, and you're looking for the VF, but we can't find it until we get our delta t. We don't know our delta t on either side, and we're told the cliff is 50 meters high. It's falling down, so that's down. And so, of course, we have to start with the quadratic. Okay, so we have delta dy is equal to VIY delta t, 1/2 AY delta t squared, rearranging, negative 1/2 AY delta t squared minus VIY delta t plus delta dy equals 0. So negative half times negative 9.81, this will be 4.905 meters per second squared delta t squared minus was 80 meters per second sine of 40 delta t, and then minus 50 meters equals 0. And so then fill it into your equation. Negative will be 80 meters per second sine of 40 plus or minus square root negative 80 meters per second sine of 40, and that gets squared, minus 4 times 4.905 meters per second squared times negative 50 meters. And all of that gets divided by 2 times 4.905 meters per second squared. So delta t is equal to, oh, I guess I could figure out what 80 sine of 40 is. It's 51.423, and there's other digits that I promise I'll leave in my calculator. Meters per second plus or minus, so under the square root, we're going to square that 51, and we get 2644.33, but yes, there is more digits, meters squared per second squared, plus 4 times 5100, 981 meters squared per second squared, and again, all over 9.81 meters per second squared. So we have 51.423 meters per second plus or minus, so under the square root, when you add them together, you get 3625.3258 meters squared per second squared, 9.81 meters per second squared. And so delta t is equal to 51.423 meters per second plus or minus, take the square root, 60.2107 meters per second over 9.81 meters per second squared. So you're going to have two possible answers, one with the plus And when you do it, it works out to be 11.37958 seconds, I believe. And